Hi Math 3 and welcome to part 1 of your 3.5 notes. It shouldn't be too long, all right? So the first ones here tell us that we need to solve these equations. So looking at number 1, this follows a well-known factoring pattern, all right? So looking at this, I have two terms separated by a minus sign, all right? And there's something special about these two terms. They're both something that I can take the square root of. I can take the square root of x squared and I can take the square root of 64. So this equation follows the factoring pattern of difference of squares. All right, and hopefully you learned about this last year. Basically, difference of squares is when you have something squared minus something squared. The way that you factor it is you do a minus b, a plus b. And to find a and b, you just take the square root of each of these. So, for number 1, I can take the square root of x squared, I get x. I can take the square root of 64, I get 8. So then I follow this factoring pattern. I'm going to do x minus 8 and x plus 8. All right? So this factoring pattern is known as difference of squares. Then I go ahead, I'm going to take my factors and set each of them equal to 0. Once something is completely factored, you can solve it by setting it equal to 0. So we're going to do x minus 8 equals 0 and x plus 8 equals 0. We solve and we get x equals 8, x equals negative 8. So the solutions here would be x equals 8 and x equals negative 8. Next one. So I want us to solve this. Now again, this is a quadratic. So I guess I probably should have pointed that out with number 1 as well. These are all quadratics. That's a quadratic. This is a quadratic. I know it's a quadratic because the highest power is x squared. All right. Basically, there's different ways to solve quadratics, but the easiest way, if you're able to, is to just factor and set it equal to 0. So that's the same thing we're going to do here. All right. We're going to factor this bad boy. We look and we're like, well, I got to figure out what multiplies to give me a negative 7 and adds to give me a negative 6. So I got my negative 7. Negative 7 doesn't have that many factors. You could do like positive 1 and negative 7, or you could do negative 1 and positive 7. I want these values to add to give me a negative 6, so I'm going to pick these guys. So I'm going to do x plus 1, x minus 7, because when I add those together, I get a negative 6. Then I go ahead and I set those terms equal to 0. So we do minus 1, x equals negative 1, plus 7, x equals 7. So that would be our solution there. All right. For number 3, it's actually way easier. They've already factored it for us. They did all the hard work. So now all we need to do is set these factors equal to 0. So I'm going to do 2x plus 1 equals 0, and x plus 5 equals 0. So now we need to solve for x. We're going to do minus 1. I get 2x equals negative 1. And divide by 2, I get x equals negative 1/2. We do minus 5, I get x equals negative 5. So my two solutions here would be x equals negative 1/2 and x equals negative 5. I'm going to move this so I've got space to do my next problem. Those would be your answers there. All right. So now we got another division problem. Now, one thing I wanted to point out, on the ready, set, go, you're asked to give a multiplication statement. So I'm going to explain how to do division again, and then I'm going to show you what they mean by a multiplication statement, okay? So if we look, let's go ahead. They want us to divide, right? So we're going to go ahead and take this term and divide by this guy. So I get 2x to the third minus x. That's going to give me 2x squared, all right? Then I'm going to multiply this guy by this guy. All right. So when I do that, I get 2x to the third plus 10x squared. Then I need to go through and change my signs, right? So this becomes a negative. This becomes a negative. I'm going to go ahead and subtract. I end up, these guys cancel out, and you get 12x squared. Then I got to bring my plus 28x down. So now I'm going to go ahead and take this guy divided by this guy. So I do 12x squared divided by x. Oh, sorry, I guess I'm just dividing it by the first term. Sorry. Divided by that guy. So then you end up with 12x. All right. So now we're going to multiply the 12x by this binomial. So I'm going to get 12x squared plus 60x. Then, of course, we need to subtract or just change the signs. Same idea. And when I subtract, these guys cancel. And I get 28 minus 60, which is negative 32x. Then I'm going to go ahead and bring my negative 160 down. And I'm like, all right, I've got a negative 32. What can I multiply this by? So I'm going to do negative 32x divided by x. And I get a negative 32. All right. So again, we're going to multiply this guy by this binomial. So we do negative 32x. And then 5 times 32 is 160. So we get a minus 160. Then, of course, always change your signs, right? So we go through and do that. We get a remainder of 0. So our answer to this problem is 2x squared plus 12x minus 32. Now, what do they mean by a multiplication statement? Well, I want you to just think about just regular division, okay? Like if I gave you something like 15 divided by 5 equals, we know that would be 3, right? The multiplication statement would be that 3 times 5 equals 15. So basically the what you divided by in your answer, those multiplied give you this guy under the hat. All right? So that's what we're going to do here. We know that this x plus 5 times 2x squared plus 12x minus 32 has to equal what's under the hat. So that's going to be our multiplication statement. So we're going to say, hopefully I don't run out of space here. We get x plus 5 times 2x squared minus 12x minus 32. And then we would say that, I did run out of space, that equals, I'm going to have to do it on 2 separate lines. That equals what's under the hat. So we get 2x cubed plus 22x squared plus 28x minus 160. So that would be our answer there. All right. So your answer to the division problem is this, but then your answer to this, actually it's the whole thing. Your answer to this multiplication statement is that these two values multiplied are going to equal what is under the hat.